Hi everyone, welcome back to our channel. This is the second video of our database management system series. In this video, we will be talking about data models on the structural level. But before we start, let us discuss on what we studied on in the last video. If you haven't seen that video, link will be in the description. Please go and check out. So, in the last video, we were mostly discussing about what is the importance of database management system. What are the type of database management system? What is database management system? So if you recall the types of database management system that was there in last video, it was mostly RDBMS, NoSQL, graph based, document based, object based. Okay. So these are some of the categories of DBMS that we discussed last time. But if you try to broadly classify them now, we can easily classify them into two broad categories, that is RDBMS and NoSQL databases. Okay. In this video, we will discuss mostly about these two broad classification of database management system, why they are different from each other, what are the pros and cons of each of them, and why in certain scenario we should use a particular type of database management system. Okay, so let's start. First topic of this video is Introduction to Relational Database. So these are some of the example of relational database servers that you see on my screen. So let us understand what is the definition of database management system and its key features. So as it is written over here, relational database organize data into table where table consists of rows and column, which in simple word mean a relational database management system stores data into a tabular structure in your Excel sheet structure. Okay. Now its feature says the relational database follows a structured schema. The structure is the same, rows and column structure. Data is organized into predefined tables with a fixed number of columns and data types. Okay. Now what does that mean? Let me give you an example. So in my system, I have Oracle database. Let's suppose I have a table named employee. Okay. I will be checking what is the description of this table. Okay. By description means I'll try to understand the structure of the table. Okay. So this is the structure of the table. Okay. The table, the column names are already decided. The type of data they will be storing is already decided. If they can store null or not, that is also a field that is also pre-decided. So what is in the feature we studied about the same. Whatever data you want to store in the DBMS, you need to specify its structure before. Okay. It's not that today you have decided that your employee ID will be a number of 10 digit or maximum 10 digit, and tomorrow you want to save your employee ID as a string. That is not possible. It follows a strict data structure. Okay. Now moving on to second property or second feature. The second feature says that your RDBMS follow asset property. Asset property is a vast topic on its own, but I'll give you a sneak peek of what it means. Asset contains of four letters A, C, I, and D. They represent different uh, feature of relational database. So A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Now let's go back to our database. So this is the database. Okay. Let's suppose I'm trying to insert this particular data into my employee table. I'm trying to insert a row. Okay. So this got inserted. Now I'll do a select all. I can see a data over here, right? Let's assume a scenario where in between, while I was executing this command, in between you lost network or something. Okay. What will happen? Will your employee ID and employee name will be saved and your employee status won't be saved? No. That can never be in RDBMS. That is the point atomicity is trying to say. Either it will complete the transaction. By completing transaction, it means here it will either insert all the data or it won't insert at all. So in that case, RDBMS always follows atomicity. The second is consistency. So let's suppose you have an employee table over here where you have employee ID, employee name, and employee status. Okay. The second table is some address table or something where you have same employee ID but a different name. Okay. And you're trying to make some changes over here. Like you want to do some changes in the employee ID. So RDBMS won't allow you to do that because RDBMS always store data into a consistent manner. If you're doing changes in here and that data is related to some other table, you'll have to do change over there also, else the change will not be done. You will get an exception from RDBMS. Okay. The third is isolation. Okay. So let's suppose I'm executing this delete command and this select command together on the same table, or the delete command and insert command together in the same table. So what happens if you want to delete a record and then insert the same record? Something like that. Will they overlap each other? No, they won't ever do that because isolation means every transaction that happens in a particular database that is independent of each other. They never uh, intersect with each other. They are independent. One of them will be performed first and later the second one will be performed. Okay. So this was the isolation, and last one is durability. Once you insert record into your table, it will always be there in your server. So that was durability. Okay, now moving on, we'll get to know in this slide about NoSQL databases. These are some of the examples of NoSQL databases. As I was mentioning, NoSQL database is completely different from RDBMS. They do not have a complete fixed structure. They are of various kinds. So that's what is written over here. NoSQL database comes in various types, including document oriented, key value, graph based. So their key feature also includes the same. The first feature that our NoSQL databases have is they do not have a strict digit structure. While inserting the data, if you think that you want to insert a document or an object, you can do it. You can change the data structure. That is the flexibility of NoSQL database management system. Second is it follows CAP theorem. Like acid, CAP also has some meaning. CAP has three letters and C stands for consistency, A stands for availability, and P stands for partition tolerance. So what does mean by consistency? The consistency means that your data will be consistent throughout the database. Okay. Availability is something which we do not see in NoSQL databases. Sorry, in RDBMS. Availability means, let's suppose you wanted to fetch a data which you have inserted a few minutes ago and it didn't get inserted. Okay. So what will happen? You won't be able to fetch data even if there is a condition where you have no network. That is not the case with NoSQL data. You will get some records always. That is known as availability. And third is partition tolerance. Partition tolerance is uh, generally NoSQL databases store their data into a node format. A node format means all the data are stored somewhere in a parent-child relationship. So once you there is less chance of losing a data. Okay, that's why it is partition tolerant. Now, since your data is always stored into a parent-child relationship, you can add an additional server and fetch data from there, store data over there, fetch data from there. So that is making your applications more scalable. Okay, that is making your database more scalable. So that is one of the key point of NoSQL database, that it is scalable. And fault tolerance, as I was saying, even if you have network error, you will be able to do some some query or some changes over your database. Okay, so I'm having a MongoDB into my system. Let me connect to it. Let's suppose this is my database I've created. I want to create a new collection named as know-how. Okay, so here you see the option to add data. You can import JSON or CSV or insert a document. Okay, I have a sample JSON with me. If you see this JSON, it it has only data. There's no structure defined over here. If you'll see, it has name, language, ID, and some details, but it does not have a structure like RDBMS. It doesn't define that, okay, it will be of string type, it will be of number type, should have 200 characters or something. Okay, I will select that, import it. Okay, so it got imported. Now you can save and use this data. Okay, so this is the benefit of NoSQL databases. Now at this point of time, we know both kind of databases. Okay, now we'll try to compare them on the basis of certain parameters. The first parameter will always be data structure. So data structure, as we already discussed a lot, RDBMS has a rigid data structure, and NoSQL is allowing you to having flexible data structure. On the fly changes you can do. Okay, schema, same. RDBMS has a fixed schema, whereas NoSQL is schemaless. Okay, query language. Okay, so what does query language means? While I was inserting data into RDBMS, my Oracle server, you saw that I was using certain commands, right? Select, insert into table name, values, certain data. Or for retrieving data, I use select all from table name. Okay, this is a special kind of language known as structured query language. So all RDBMS uses this language to communicate. Okay, whereas in NoSQL, you do not have such languages. You have some APIs. MongoDB has a language of its own. So it is more easier for the user to use NoSQL databases, as SQL language is a bit complex. Okay. And the last one is scalability. We have discussed over this topic also, that in NoSQL database, as data are stored in Node, you can add a server and make your application more scalable. But in RDBMS, let's suppose you have an Oracle server which exhausted its capacity. You cannot add one more server and store data into that and retrieve from that. That is not possible. Either you will have to increase the memory or increase the resources. That is the only choice. So this is not scalable. Okay. Now moving to next slide, which is pros and cons of RDBMS. So pros and cons. Pros, we have already discussed about cons first, that we have scalability challenges with RDBMS. It has rigid schema, which is not letting user to be flexible with the data structure. But we have certain pros also. The pros first is it is well defined before you start to store data. Okay, so it is always ensuring your data integrity. Secondly, asset properties always guarantees your transactional consistency, which means let's suppose you are making a payment, okay, to a um, making a payment to an e-commerce platform. Your payment either will be done or it will not be done. It will never be holded into one stage, okay, and that is because of atomicity that RDBMS follows. So this comes handy in such critical situations. And the third is suitable for complex queries and relationship between tables. Okay, so let us assume application where you want to design your database which are very correlated with each other. Let's suppose you are an e-commerce platform. You have an order table, you have a product table, you have an user table, you have an uh, payment table, and everywhere data is communicating with each other. Okay, Everywhere all tables are communicating with each other, they are in relationship with each other. If you want to fetch some data from all of them together, let's suppose when we go and talk to Amazon Help Center for some of our queries, like okay, last time I purchased this particular item, but my transaction was failed, can you give me a refund or something like that. They go and check all your data, right? So they fetch data using such complex queries. That won't be possible when you are using NoSQL, because in NoSQL sometimes the data can be inconsistent, but in RDBMS it will always be consistent. Okay, so this was the pros and cons. Now we'll move to next slide where we'll talk about pros and cons of NoSQL database. So pros we have already discussed. It is very scalable. It is providing user an excellent performance. Secondly, it is giving you the immense amount of flexibility with its no schema architecture. And third, in today's world, users have multiple kind of data. Real-time real-time video streaming data, your document data. So in that case, your NoSQL database comes handy. The cons is, as we discussed, they don't have standardization, so sometimes your data can be inconsistent and they cannot be used for complex queries. Now we have talked a lot about these type of databases, their pros, their cons, their architecture. So we should be able to figure out in what scenario we'll use what kind of database. So as we were discussing, we'll use relational database where A, your transaction requires ACID compliances. B, your application involves complex queries. And three, you already have predefined structure of your data. You know what kind of data you want to store. Okay. And second, go for NoSQL wherever you are dealing on large amount of unstructured data. You don't want a fixed structure of your data, but you want your application to be highly scalable. You want a user to be having flexibility to change the data structure of data on the fly. Okay. So now you must be wondering, where do we use this in real life? So as I was talking, e-commerce banking platform, they generally in real time also uses RDBMS, whereas NoSQL database can be used by applications like Netflix or like Uber, where they want to track the live location and traffic and graph. They uses graph mode of NoSQL databases. That is all about this video. I'll see you soon with the next video. In case you have any queries on whatever we covered in this video, or you want me to make a specific video on certain topic related to database, or you want me to make a video on certain topic of database, you can let me know in the comment. Thank you. Bye.